Our second stop on the tour of Chapter 8 is 8.1. We're going to use matrices to solve systems of equations. And this is going to be a little different from how we set them up in 8.2. This is going to be using augmented matrices. And we're going to go back to our good friend Gauss and his buddy Jordan. And we're going to use reduced row echelon form, which we all enjoyed some row echelon form. So it's going to have some similar vibes to what we did last chapter. First things first, we need to learn about what an augmented matrix is. It's a way of writing a system of equations as a matrix. And again, we're going to take those coefficients of the variables. And then there's going to be this mysterious dotted line right here. And then we're just going to go ahead and throw in what each equation is supposed to equal. This is what they call an augmented matrix. It seems a little more mysterious than the matrix equation we learned to set up last time, but that's what's called an augmented matrix. And so given this augmented matrix, can you go backwards? Can you tell me what system of equations that represents? Well, I know that these are the coefficients of the variables. Do you notice it's only kind of a 2 by 2 over there, right? So there must only be 2 variables. So that must mean that's a 5x and a 6y, which should equal -10. And a 4x minus y equals 3. So we could solve that by graphing, substitution, elimination, and now we'll learn another way today how we can make our calculator do it in matrix form. So let's talk about, we know row echelon form, but we've never done it in matrix form. Row echelon form, same sort of idea though. It's got the triangle of opportunity. TM, with all those zeros cleared out in the bottom corner. A little addition that I like to add for row echelon form, I like to get the 1s along the diagonal, as long as it doesn't make any fractions initially. Now, along comes his buddy Jordan, and he helps him out a lot, and he goes for, well, why not go ahead and do a second triangle of opportunity up in the other corner? Heck yeah. Because then what does this represent? Well, this is going to represent the coefficient of the x. 1x equals 4. 1y equals 6. 1z equals 7. So having that diagonals of 1 is going to be super important. So we just know what our x, y, and z equal in the end. So all of the steps on this are going to feel just like when we did our Gaussian elimination last chapter. We're just going to clear out twice as many spots. And we will be doing this by hand. There is a way to get your calculator to do it, but of course I'm going to make us use our math minds as well. When it says Gauss-Jordan elimination, that's your cue that we're going to clear out the Gauss triangle, I like to think of it, and the Jordan triangle. That's probably not proper terminology, but I make things up, so. First of all, let's get our, what do we call it? Our augmented matrix set up. I really think you're going to like this because we aren't going to have to deal with confusing ourselves on whether that's a 2 or a z, right? Also, I sometimes feel like the notation gets a little less confusing than it was before. Now remember, Mrs. Backlund's strategy is I like to target this number first, and I think the best way to target that number for me seems to be taking that top row times -2 and then adding it to that second row. And this is kind of the notation I tend to use instead of like writing things out really complicated. Like, I try to do some of this in my head. Is it dangerous? Absolutely. So my top row is going to stay the same. Bottom row going to stay the same. My middle row is going to change. And I'm going to think about this row times -2 added to that row. So I'm going to get a 0 here. -2 plus -1 multiplied by -2 plus 3 multiplied by -2 would be -26 plus 9, -17? We're a sixth of the way there, people. All right, let's clear out the 3. To clear out the 3, I believe I'd like to take the top row times -3 and add it to the bottom row. And again, I'm trying to do that in my head. If that's too much and you want to show some work on the side, all power to you. I'm going to keep the top row unchanged, the middle row unchanged. And the bottom row is going to be the top times -3 plus the bottom. -3 plus 2, -3 plus 1, -39 plus 38. Whew. Great. Finally, I'm going to clear out this -1. If I use the top row, I know that's trouble and I'm going to screw up this 0. So I've got to use that middle row. And so I believe I will take this guy times -3 and then add that row to it. I think that's what I got to do. Top row unchanged. All right, nothing here. 0 here. 1 plus 6 is 7. -17 plus 3 is -14. Amazing. All right. Gauss, you've done your job. I see a triangle of opportunity. TM cleared out. You know what I want to do right now? I think I'll just go ahead and take this row times 1/7. Why not? Because then I can get a 1 right there. And then we'll move on to Jordan's job, which is to clear out the other triangle, right? Are we having fun yet? Normally now here's where we would do our back substitution, but we're going all the way to what they call reduced row echelon form. We've got it in row echelon form, but we're bringing in the reduced with our friend Jordan. So let's go ahead and just like we went here, here, here for Gauss, we're gonna go here, here, here for Jordan. So I'm gonna target this 1 first. If I try to use the top row, I'm gonna start screwing up my zeros that I don't want to mess with. So I'm going to go ahead and use the bottom row for sure. I think I'm going to -1 this and add it right there. Amazing. And as long as that row's kind of solved up, why don't we -1/3 that row? Get that 1 in the middle. Two more. Can we do it? Okay, my next target is this guy right here. I'm going to use the bottom row times -1. To me, this is showing my work. If I mess it up, the teacher has to find it. Whew, last step, here we are. final one, final elimination. I'm gonna -1 this row, add it to the top. Yes, sir, here we go. I really hope that's the right answer. Now remember that top is the coefficient of the x. Here we've got a coefficient of a y, and here we've got a coefficient of a z, right? So what that translates to is that my x is equal to 10, my y is equal to 5, and my z is equal to -2, or as an ordered triple, just like that. I'm pretty happy I got integers, but I'm a little bit interested in double checking that in at least one of those equations up there. It's 10 plus 5 plus -2 equal to 13. Yes. Oh, that's good news. It should work in the other two equations too, but I'm pretty happy about that. Now, wouldn't you know, our calculator can also do this for us. And I do believe I would let you use a calculator every time we're doing one of these 4 equations and 4 unknowns, because holy, look at that. 1, 2, 3, 4, 5, 6, 12 zeros that we'd have to clear out on this. Let's go ahead and make our calculator do this. Let me show you how. All right, so second matrix. Let's edit matrix A. What are we gonna need here? We have definitely 1, 2, 3, 4 rows. 1, 2, 3, 4, and then that extra 5th column. 4 by 5. And we'll enter our coefficients. This is annoying, but we know it's not nearly as annoying as all that work we just did on the last problem. Got it. Matrix A, the augmented matrix, all entered in. And I would like to use Gauss-Jordan elimination to put this augmented matrix in reduced row echelon form. If only this calculator were voice activated, but it is not. So I will go to the blank screen. Here we go. So we're gonna go to second matrix. It's under the matrix math. It's actually down towards the bottom, so sometimes pushing the up arrow is easier, but here we have row echelon form. That's for Gauss, but we want to do Gauss and Jordan all at once, so we're going to do the reduced row echelon form. So we're going to select reduced row echelon form under math, and I just entered all that junk into matrix A, so I'm going to go to second matrix and choose the name matrix A. There we go. Are you ready? Isn't that glorious? Okay, sometimes I love technology. I know that x equals -12, y equals -4, third column was z equals 1, and the fourth column, they ran out of letters, they used w equals 2. Amazing. What a nice shortcut. I might even use that on the ACT, only if it feels like it'd be faster than solving it using some other method. So I could solve any system of equations using an RREF, but only if I get fast at typing in matrices, I suppose. All right, hope you learned a lot. Your assignment is going to have you do some of those by hand. I hope you enjoy.